Sorry, this page by using the Mandarin. I will introduce some I will introduce the different energy storage systems, and you can see the energy storage technology. We can have the electrochemical, and we can separate to the four parts. One is the electrochemical, the second is the electromechanical, the third is thermodynamic, and the fourth the mechanicals. In the next page, in the follow page, I will be introduce some of the energy storage technique to you. And the one is the mechanical storage. Mechanical chemistry can the basic concept like the pumping hydro storage and of the compressed air energy storage of the firewall energy storage. It always using the mechanical power. We can storage the power, and we using the mechanical. We use the mechanical to charge or discharge this power to the grid. We can use the power. And this is one of the example from the PGME using the compressed air can do the energy storage system. When we have the extra power in the grid, we can push this air compression into the one gas reservoir. So, and then if we need to the power, we can release this air to the pressure turbine, and the turbine will be driving the generator, and the generator will be the general power to the grid. So you can see is the like example from the PGME is using in the United States. It's the rate power in kilowatt is very large, about 300,000 kilowatt, and it's during a very long time, almost 10 hours in one cycle life. Okay, the next page is the hydrogen pumping energy storage system. Is the example in the Taiwan hydraulic pumping system. This power plant is in the middle of Taiwan. You can see after the pumping storage unit was completed in 1993, it became one of the largest pumping storage hydroelectric power plant in the world. At the present, pumping storage unit part is still the largest in Southeast Asia and the 10th largest in the world. You can see the power capacity is 1,668 megawatt. It's the capacity. How can we realize this? It's a capacity. You can compare with the nuclear power. Its capacity is larger than the one nuclear power. Its annual generation is 2 billion kilowatt hour. And the next second kind of chemical energy storage system is one is the lead acid battery. The lead acid battery is we always using in this battery in like in the automatically of the car or bus, and maybe some kind of the traditional battery system. Its advantage the lead acid battery is developing the technology with the existing infrastructure for end of life recycling already in place due to the automatic industry. and it's a relatively efficient, the long cell discharge rate, but it also has some disadvantage. It's susceptibility to the high depth of the discharge and the low energy density and the potential hazardous the material. So you can see if we using the lead acid battery in the one energy storage station, you can see this page in the slide. We need to use the huge battery cell in the one station, and we already it's using in the lead acid battery in the starting the vehicle engine as well as for the backup power supply and for the grid energy storage. The technology is mutual for the using ancillary service such as the uninterrupted like interrupted UPS with the demonstration application for bulk energy storage system. The lead acid battery always demonstrates the storage between the 3 to the 10 megawatt over a period of an hour, with the example being the Medakata lead acid battery project with an installed capacity of 1 megawatt. And you can see the application in the United States, Hawaii. United States is the integrate with the wind power. So the rate power is 10 megawatt and the duration is 0.65 hours. So it's a service for ancillary service ramping and the renewable energy capacity forming and the renewable energy time shifting. And the second example is the location also in the United States, in the New York, and this the lead acid battery system. We apply the service in the demand response, like electric bill management and the electrical energy time shift and the electrical supplier capacity. And the second battery, we always know the lithium battery is this is the new technology compared with the lead acid battery. This battery has some advantage like high energy density. It ordered 400 watt hour. 400 watt hour. The ion battery are able to tolerate more discharge cycle than other technology. It's high efficiency, but also some disadvantage. The ion battery has a high cost than the other technology, and it's a negative effect of the overcharge over discharge. If you using the ion battery, when you overcharge when you over discharge, you will be make some huge damage aspect. Maybe would be that the battery can be had no function to use it, and also the potential for issue associated with the overheating. And the lead ion battery we always apply very similar like very good applications such as the frequency regulation, voltage regulation, and the integrated of the renewable energy source. There are limited worldwide commercial installation to the day. However, the technology had been deployed on power network. For example, 20 megawatt installation was commissioned in the 2011 in the Junction City, New York, United States, to provide the regulation service. I can show you some example. One is in the Jamestown, South Australia. It's the employed by the Tesla. Is the rate power is 100 megawatt and durable 1.25 hours. Its service using case is the frequency regulation, renewable capacity forming, and renewable energy time shift. And the second example is using Ohio, United States. This is battery is only applied to the frequency regulation. And this slide shows the Tesla big battery official switch in South Australia. Is the same last page, 100 megawatt battery system in the South Australia and deployed by the Tesla. This is the 100 megawatt 129 megawatt hour battery system was the switch on in the November 2017, and the pair with the wholesale windfall is about 230 kilometer north of the Adelaide. The Tesla big battery system had been installed on the South Australia grid when it was expected to the time shift a small amount of the wind power and provide the network service and emergency backup in case of a major problem. You can see in this page, we in the initial purpose, the Australia government hope the big Tesla big battery system can supply to the time shift. You can see the blue line is the power generation by the wind turbine, and the red line is the low usage. So you can see the power generation from the wind turbine would be higher than the low usage in some special time. So the Australia government hope to have the battery storage system to adjust the power smooth. So it can provide a request area is a 70 megawatt of the backup to help meet the critical peak in the day before it's open. Enter into the frequency control and the ancillary service market and the discharge at the full capacity. And you can see this one, when the low using in the night time, so the battery system can adjust the energy, and you can discharge the battery to the grid and balance the grid power. In the daytime, you can see the blue part is blue part is come from the power generation from the wind turbine. But it means in the daytime we have extra power in the grid. It will be make the grid imbalance and will be cause the grid crash. So this big battery system can discharge to the 70 megawatt into the grid during the afternoon peak, and using the wind output is had the storage early in the day. So the intervention meant that less gas generation was needed, and the price was moderate. So that is expected to be a pattern in the future. And the famous record in this battery system is what happened in the 2028 in one of day of the 2028, one of the biggest coal unit in Australia, Loya A3, is what happened. He happened to trip in the trip without this tripping without warning at the 2 a.m. and suddenly lost the 560 megawatt and caused the slapping in the frequency on the network. But in this time, the lower A unit had the finished trip, the 100 megawatt, 29 megawatt hour battery system had the response injection 7.3 mega power into the network to the help the address to the slap in the frequency, and that had fall below the 49.8 hertz. So it means itself is the power grid, and if we in that time the battery system without is under construction. It means the battery system cannot charge power to the grid. It would be had a crash of the power grid in Australia when the Royal H3 trip without warning. So it also shows the application of energy storage has the extra function in the ancillary service. And the battery system, the sodium sulfide, also called the NAS battery. This is the technology come from the NGK of the Japan company. This is the advantage: high energy density, long life cycle, quick response, efficiency in the charge or discharge cycle, and able to the tolerance of high number of charge or discharge cycle. But in some disadvantage, because you need to heat, this kind of battery need to operate in the high temperature environment, especially the temperature will be higher than the 300 to the 400. But it also has some potential safety issue with the more sodium, and has some fire issue at the Japan installation. In always application, there are over 300 grid application of the sodium sulfide battery worldwide, with the majority of the located in Japan. But this is always using for the many grid applications such as power quality application, grid stabilization, and the integration of the renewable energy source. One of the biggest sodium sulfide battery is 34 megawatt capacity had been used integrated for the photovoltaic wind farm in Japan. The battery store the energy generation at the night and combine this with the wind farm output during the time of the grid demand in the day. Okay, we next page is some application introduction. We will show you some application in Japan and in United States. They all using the sodium sulfide battery. One is battery system in the Fukuoka, Japan. It's a service using case the frequency regulation, renewable capacity forming, and you can see the rep power is 50 megawatt, and the durable higher than the 6 hours. It is a very long durable period compared with another battery system. And the second is sodium sulfide battery system is located in the West Virginia, United States. It's the service using cases is electrical energy time shift, electrical supplier reserving confirming, and the third grid connection, residential transport transmission, distribution, upgrade, deformer. And the another battery system is the flow battery, especially we mean the perpendicular flow battery. Its the advantage is less sensitive to the higher depth discharge. Their electrolytes, they always use the liquid type. So compared with the another battery, it would not have the had some fire issue, so it can able to tolerance large number of charge discharge cycle and reduce the leakage of the cell output being the reduction to that of the low the performance cell. And but it has some another disadvantage is very is lower than the another battery system, the low energy density and not the commercial nature. But now in the world, some of the commercial using the flow battery can be used for mainly grid applications such as low balance, standby power, and the integration of the renewable energy source. There are limited worldwide commercial installations to the day. However, the technology has been deployed on the power network. For example, the 200 kilowatt flow battery was used to store the renewable energy from the wind farm, and the battery was operated between the 2003 to the 2008. You can see the partial of the flow battery. We always call this the reaction cell. Like this one, you can see the liquid flow in the tube, and the electrolyte will be changed is type to between the charge or discharge. And some application in the Japan and of the China, the biggest flow battery manufacturer is the Sumitomo, Japan. Their vanadium reduction flow battery is the largest the largest in the world. The rate power is 15 megawatt, and the durable had 4 hours. It's a service using case the renewable capacity forming. Another flow battery manufacturer is in the China. It's located in the north of the China, and its rate power is only 2 mega, but the duration is also 4 hours. But the service using case is more than the Japan case. It can do the frequency regulation, ramping, and renewable capacity forming, and renewable energy time shifting. And after we talk about several kind of the battery system, let me introduce this application. And because in the why we want to using the battery system in the integrate with the grid, because the power plant you need huge money and the long time to installation and construction. But the one of the battery system is easy than the power grid, and we can very fast to let the battery system integrate to the grid, and has some application. You can see the energy storage system, like a battery system, if we had the grid scale energy storage, we can use it use the high power usage. You can do the power quality control and improve the grid resilience. And if we using the high energy use, we use it in application in the high energy, you can do the energy management and decouple the generation from the demand. and we want to separate understand its application. We can understand from its discharge duration from the second, minute, and hour. If you using the energy situation in the second scale, you can do the voltage of the frequency regulation, transmission smoothing, and the reactive power control. If you using the mini scale, you can synchronous reserve and interruption power supply and backstop. And our scale is a low leveling, peak shifting, energy trading, and islanding operation, the integration of the renewable energy. So you can see in this page, you can the battery system had a lot of the application and to the grid, and you can using the different application and make the different business model. And in this page, you can see more clearly. You can I want to introduce about the renewable energy stabilization. You can see because the PV output is we all know the renewable energy, especially the PV power, is very unstable and corresponding to the weather. So today is the sunny day, is the power power generation large, and the cloudy day, the power generation is small. But when in the some place is maybe very transfer very quickly from the sunny day to the cloudy day. Because the PV system, its power generation had a large fluctuation. This fluctuation would because the grid power grid unstable. But if the power grid unstable, it would be it would be that the power quality very bad. So it will be affect some equipment, especially in the infrastructure. So if we can integrate with the battery system, you can see the backlight when the PV output the generator to higher, we can let the battery system charge it, and then if we need to you had this peak, we can charge this the battery. When the power drop down, we can let the battery system discharge its power and to the grid, and it can make this the grid power stable than without the battery system. You can see if we integrate the battery system, you can get the more stable output better than the only PV output. So it would be let the power grid stable than the only PV systems. And the next page is another application in the picture grid, because we always know the PV generation only in the daytime, but some area partial we need to using the power in the nighttime. But in the nighttime we didn't have the PV power. So if we want to using the PV power in the nighttime, we can integrate with the battery system. We charge the extra PV power to the battery system, and then when we need to the extra power, we can discharge the power to the grid, and we can shift in this the power demand, and let the bidding decrease. And the final page is the grid energy storage system and its application. We can have the separate its several application. The first is integrated with the renewable energy. It would be when we integrate with the battery system, it can get voltage support and some renewable energy stabilization. If we integrate with the generation side, it can have the low leverage, and the master application in integrate with the grid, especially in the transmission network of the distribution network. If we integrate with the transmission network, we can have the power factor and the voltage support, and we integrate with the distribution network, we can have the low leveling for the postponement of the grid upgrade. And another application is the integrate with the remote community of the industry side, because in the remote areas, the power quality, especially is the voltage, will not be stable. So we need to integrate with the battery system to get the more stable power quality to do the manufacture. And another is the integrate with the low voltage distribution network, and you can do the micro generation feed-in. So it is another application. The final application is with the distribution micro generation. This is some like microgrids application. You can install the PV stand on the rooftop and integrate the battery system in the home. So in the normal status, you can get the power from the PV stand, and you also can get the power from the traditional grid. But sometimes, maybe some of the more abnormal status, the power grid is the crash, and but if you have the battery system, you can continue use the power to do something. It's the advantage of the battery system distribution in the microgrid generation. Okay, that is the final passage. Thank you. Thank you for listening.